Okay, so how is everyone today? Good, I hope? All right. So, today's the 13th. All right. Okay, so the 13th. A few bookkeeping issues, just about the course. So first is that quiz 14 is on Friday, 2 days from now. Now, before anyone has a panic and thinks quiz 14. What about all the ones that came before that? Okay, fine. But why is it called Quiz 14? Yeah, it's the 14th time that we meet. Okay, so as a reminder, our meeting pattern is Monday, Wednesday, Friday, and then the numbering scheme for we meet. So like the very first time that we meet, that one's name was 0, 0, and the next one 0, 1, and then 0, 2. 03, 04, 05, 06, 07, 08, etc., right? So as it happens, today is lecture 13. This is the 13th time that we meet. So then, 2 days from now is the 14th time that we meet, so that's called quiz 14. Because, in the end, it occurs on the 14th meeting. Okay, good. So the first quiz, is named quiz 08, because it occurred right there. That will be in the gradebook soon. So in gradebook and box. Soon. So, where the gradebook is concerned, an example, one of the exercises on the quiz, its name was 010. All right. So then, in the gradebook, there will be a grade named quiz 08, and then 010. Okay. So interpreting the name of that grade, you've got to know what it means. That means that it's talking about a quiz that occurred in meeting 08, and then 010 means that just that bit. The 01 means what? It covered material in lecture 1. So the topic is from lecture 01. And this means that the quiz occurred in lecture 8. So all that last digit means, it just makes it different from the other questions that were from lecture 1. So like a different question would have been like 011 and then 012, etc. Okay. Fine. Now, where grading is concerned, if I had my way, the grades for quiz 8 would have gotten back to you much sooner. But at any rate, because this was the first quiz, and I've never worked with these particular graders before, and a couple other things, there were some wrinkles, but I think we've got them all smoothed out. And I expect generally speaking, for a quiz on Friday, you'll have the grades probably the following Wednesday. But this one, just didn't work out the way I wanted. as far as speed of grading is concerned. But I think we've got the wrinkles worked out. Now, so I'm gonna show you some quiz pages that were graded, and but before I show them, I want to point out something, and that is that at any school, like grade school and university alike, just there's laws about showing student work and things like that. So it's not permitted for me to show you grades for a student if you know who that student is, right? So if I said here's Tommy Jones's exercise and here's what they made, that's actually against the law. In the same kind of sense that you can't just walk up to a doctor and say, hey, can you tell me about her medical records? You can't do that. But it's fine for me to show you graded work as long as you can't tell what student it's from. So on your quizzes, I suspect you noticed that there were barcodes and things like that. So when your quizzes are graded, the way it works is that your quiz, I can't remember, I think it had 5 pages or something like that. I disassemble the quizzes. Only the first page has any information about who you are on it. So I disassemble the pages, and I give the grader, to each grader, I give them a stack of pages. So like, one grader would have received only the 3rd page. So that's good for a variety of reasons, but one of the reasons is that the grader has no idea who they're grading. So that's good. So here's an example. This page has no identifying marks on it as for what student it could possibly be. But interpreting the meaning here. So this question was question 010, which means that it's covering material that was in lecture 1, and 0 is just to make it different from 011. Right? As for this, the student, it appears that on this particular exercise, student did it entirely correctly. So grader just check, and then bubbled that one, which means 10 out of 10. Now, if you look real closely at it, these bubbles say 0, 1, 2, blah, 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 up to 8, 9, and then that one says A instead of 10. In the end, the reason is because when I was writing this program, the 10 didn't fit in there very good. Okay, so A means 10. So that's good. That's a good result for that student. Very good. And then to see a different result would be something like this. So like this is a different exercise that says 0 to 0. You can, that got cut off just a little bit, but you can always see it right there, 0 to 0. So that would mean that this is a question corresponding to lecture 02. And student did good, but something was not right about it. And the grader wrote subtract 3, and what was bubbled is 7, because it got 7 out of 10. Right? So then if you made 2 out of 10, that one would be bubbled, etc. All right. So now, the reason why I'm saying that is because here's another example, right? So once your pages are graded, and they'll be returned to you in 2 ways. One of them is that on Box, you'll just have there'll be a scan of it for you to look at, so you'll see exactly your stuff. Also, it'll be in the grade book. So that's nice. So I'm telling you this stuff for 2 reasons. One reason, just so you can understand what that name means. Second is that once I've returned a quiz to you, then on a subsequent quiz, there may be an opportunity for you to redo that exercise. So here's what I mean. So when you look at your result on 010, maybe you made 10 out of 10. Good job, great. But maybe you made 5 out of 10. Which is less great. And so what can happen is that on a subsequent quiz, you'll open it up, put your name on the front and whatever. The first several questions, those will all be mandatory. You've got to do those. And then you get towards the back, then it'll say something like, beyond here are the redo exercises. And if you see 0, 1, 0 on it, then that means that in some sense this is your second stab at it. Okay. Now the redo the redo policy is described exactly on written homework 003 or something like that. Maybe it's 002 or 4, I can't remember. But it's on one of those. And here's the deal, is that if you attempt the redo for 0, 1, 0, then that will replace whatever you make on 0, 1, 0, whatever you had made. So if originally you made a 5 out of 10, and then you make a 9 out of 10, now you have a 9 out of 10. If you made it, if you make a 10 out of 10, okay, then you have a 10 out of 10. But it can also go down. So if originally you made a 5 out of 10, and then you try the redo and you make a 3 out of 10, then now you have a 3 out of 10. So if you did not do the original, your grade is effectively 0. So if you don't do the original and you don't do the redo, that means that your grade for that exercise is 0 out of 10. Now, when can a redo appear? Essentially any time after I've returned it to you. With the exception of 2 days from now, there's not going to be any redos on the quiz, because 2 days, even if the grader finally, the last grader finally gets back to me and I get it posted to you today, that's not, in my view, that's too short of a turnaround. But we have another quiz in 2 plus 14 days. So then there could and will be redos on that one. Okay, when will they appear? Randomly. So then I'll put the redos anywhere after the time that I've graded and returned the papers to you. The purpose of that policy is, well, first to give you a chance to see that oh, I didn't do that, I didn't answer that question right. So I need to figure that out and study that. Also, I need to be ready, because I don't know when the redo is going to happen. So I need to be ready, at any time. So the purpose is, to give you a chance to figure out what wasn't right and to correct it, and also to maintain a state of constant readiness concerning all topics that you've seen so far. So any question about the policy? Yes? Well, they all have a different number. Like this one is 0, 1, 0, and on the flip side, that was 0, 2, 0. Yes. It'll clearly say it, and what it'll be is that the first several exercises are, you have to do those. Well, I mean, you have to do those in the sense that that's your first attempt to do those. But then there will be a page that just has instructions that says beyond this page are the redos. And you'd want to know, like, oh, I'm looking out for that 0, 4, 1 or whatever. And if you choose not to do the redo, that's fine. Nothing will change. So, like, if on 0, 1, 0 you made 9 out of 10, well, you might choose not to do the redo. Conceivably, you could get 10 out of 10, but you could also get 8 out of 10. So you might choose, well, 9's pretty good. 9 out of 10 is pretty good on 0, 1, 0. Other questions? Yeah?
And we will have our first quiz back graded for the second quiz, so we can know which sections we should attempt to redo or not?
Well, so tomorrow, I mean 2 days from now, is the second quiz. So there won't be any redos on that one, because 2 days, even if I get it to you today, I don't think that's enough time.
Fair enough.
But for you to do something meaningful. But 16 days from now, yeah. And then concerning quiz 14, which we're taking in 2 days, that'll get, now that the grading mechanism with the graders and all the paperwork and whatever is, hopefully all the kinks are out, those will get back to you soon enough for redos corresponding to quiz 14 to be on the third quiz, which will be named quiz 20. Other questions? All right. Good. And so the main the new stuff for quiz 14. So quiz 14, the new stuff, which is to say that you're seeing for the first time, is that quiz 8 was up to and including lecture 4. So quiz 14 is the stuff beyond that. So you know, like lecture 05 until the papers that we turn in today. So up to and including lecture 10. Any questions about any of this? All right. Then, you know, this is mostly I suspect we probably won't need much more like procedural discussions, because it'll just be more of the same for the rest of the semester. Okay. So now let's do math. Fine. So then when we left last time, we were talking about factoring. Oops. So then let's have one more of those, and then we'll move on to a new thing. So factor out the GCF. And then final answers. With positive exponents. Okay, so here's an example, or here's the exercise. So 40, and then how about 40, and then what? X squared y to what? 11/3, and all of that over w cubed, and then plus 28 x to 8 multiplied by y squared multiplied by w, like that. Okay, so factor out the GCF. All right. Now, for doing this process of factoring out the GCF, notice that in the expression I gave you, there's two terms. Terms are the things separated by pluses and minuses. So there's two of them. And then for this second one, this one right here, you know, it's got 4 pieces, and the names of those pieces are factors. So factors is when you have a term, and its pieces are the things that are separated by multiply or divide. So, you know, 4 terms, 4 factors, 1, 2, 3, 4. And then this also has 4 factors, because there's, you know, 1, 2, 3, because those things are, you know, separated by multiplies. Also, this one, because that's a divide. Okay, so 4 factors, 4 factors. Also, concerning the types of things that are present, in the sense of like apples and oranges and things like that, we've got these coefficients. That's you know, one kind of thing. We've got x stuff and y stuff and w stuff. So there's 4 different kinds of things. Finally, for this kind of exercise, generally the best place to start is to make it to where it's all multiplies and not a mixture of multiplies and divides. So any divisions, we would like them to be multiplies instead. So here's the only division. So there's like, what I'm saying is that in the sense that we'd like no divisions and all multiplies, this is fine, but we want to change the divide by w cubed into a multiply. How do we do that? So bring it up here? Okay. So I'll do that. So then 40, and then x squared, and then y to 11/3. So I'm bringing it up, and I want it to be a multiply, and then what do I have to write?
W to the power of 1/3.
Okay, that's not right.
Negative 3.
-3.
Equal and backwards.
So the thing that I'm using there, well, let me write this other one, is plus that 28 x to 8 y to 2 w, that. The thing that I used is that 1 over w cubed, like that, is w to -3. And then the one that, another fact, is that you could write this, that w to 1/3, that's a different matter. We have another way to write w to 1/3. What's that other way? Cube root of w. That's a different matter. So generally speaking, when you have a term, when you move something from numerator to when you move a factor from numerator to denominator, you negate the exponent. So we said, okay, we want this w cubed to move up. As a result, it's -3. But if it came to pass that we said, well, actually, I want this y stuff to move down, then what would its exponent become? -11/3, right? So to move it down comes at the cost of making its exponent negative. And if we wanted to move the x squared down, it would be x to -2. Okay, but at any rate, can you see how we got here? Okay, now there's 4 different kinds of things: the numbers, the x's, the y's, and the w's. Of those 4 things, 2 of them, in my view, are kind of straightforward: the numbers and the x's. The other 2 kinds are a little bit less straightforward because, that's a fraction, so, that's, whatever, and then that's negative, so that's a little disturbing also. So I'm going to deal in one step just with the numbers and the x's. So concerning the numbers, 40 and 28, what can we get to come out? 4, right? That's what's common to both of them. So 4 can come out. And then concerning the x's, what can we get to come out? X squared. So doing that, we need to fill in these parentheses. So if concerning just that term, if we factor a 4 out, then the coefficient would be 10. And then we factored out all of the x's, so those are all gone. And then now we didn't mess with the y's at all, so this is just copied. So y to 11/3 multiplied by w to -3. That's the first term. And then what about the second term? What will we have? So what will its coefficient be? 7. And then concerning the x's, what will we have? 6, right? X to 6. Because 2 of them left because they factored out. And then we didn't mess with the y's or the w's, so just copy those down. So y squared w. Any question about that one? All right. So now I'm going to deal with the y's. Just the y's. I'm going to leave all the rest of the stuff alone. So concerning the y's, I see that this term has 11/3 that it could contribute. And this one has 2 that it could contribute. And the rule is, it's weakest link. It's whoever is smallest is the one that determines what's going to happen. So how much y are we going to factor out? 2. Now the reason is because, 11/3, well, that's almost 4, isn't it? So that's more than 2. So this is the winner. That's how much gets factored out. But in order to help us with the arithmetic and things like that, this is 11/3, and it would be good if we could write 2 in terms of thirds. So in terms of thirds, how much is 2?
6.
It's 6/3, right? So the choice was between 11/3 and 6/3. 6/3 is the 1. So I'll factor out y squared. So this would be 4 x squared y squared. And so now, we want to deal with this. So the coefficient's still going to be 10 because we didn't mess with that at all. And now, how much y do we have here? 5/3, right? Because it's taking away. Is that this one had 11/3, but because we factored that out, that means that we took away 6/3. So 11/3 minus 6/3 is 5/3. So I'll write that here. So 11/3 minus 6/3 like that. And then we didn't mess with the w's at all, so I'll just write w to -3, and then plus 7 x to 6. The y's are gone, we took those, and then we didn't mess with the w's, so that's still there. Okay, so I wrote 11/3 minus 6/3, so now I'll simplify that. So 4x squared y squared multiplied by 10 times y to 5/3 w to -3 7x to 6 w. Okay, and I don't need you to write this step in the middle, as long as you get this right. Okay, so 11/3 minus 6/3. Any question to here? Now, at any time, if this is getting, you're a little bit unsure of yourself, you can always check by doing the following. Like, for example, on this step right here, you could say, well, is this really right? And the way you check is you say, well, I've got this thing multiplied by that sum. So you could distribute this back and say, well, I'll do this times that. Right? This thing times that term. And what do you get if you do this factor times that term? Well, you get that, right? Similarly, if you multiply this one by that one, what do you get? That one. So you can always go backwards. All right. Now, concerning this, we've dealt with the numbers, the x's, and the y's. And you can see that because, well, here, this coefficient is 10 and that coefficient is 7. Do those have any common factors? No, so we can't do anything. We can't get any more number to come out like that. All right. Now, in the parentheses here, do you see that there's some x's? Yeah, there's some x's. Now, the way the x's are arranged, can we get any more x's to come out? No, right? Because even though that term has 6 x's it could contribute, that one doesn't have any. Similar story for y's. All right. So concerning the w's now, this one is this one has -3 it could contribute, and how many? This one? 1. This one has 1 it could contribute. So now the rule is, again, weakest link. Whichever one is smaller is the one that wins. So which one? And this is where, negatives sort of cause the physical analogy of chains and things like that sort of breaks down. But at any rate, this one is the winner. And if the chain analogy, you don't like that, then you can sort of look at these two numbers and ask yourself, okay, now which one would be the worst case scenario for my bank account? Well, yeah, okay, neither one of them is awesome. Neither one of them is awesome, but that at any rate that one's worse, right? So that's the one that determines the behavior. So that means that w cubed, w to -3 can come out. So then we'd have 4x squared y squared, and then out comes w to -3. And now we need to figure out what goes in these parentheses. So concerning the first term, that one, we didn't mess with the number at all, so that's just 10. We didn't mess with the y's, so that's also not changed. And then we took out w to -3. So, you know, that bit's just gone. Fine. As for the second term, what do we have? 7. Because we didn't mess with the 7. X to 6. Because we didn't mess with any of the x's. And now here's the place where, again, many students go off the rails. So what about the w? I heard -2. I heard -4. I think I heard 4. One of these is right. So look at the way it works. Is that whichever one we're factoring out, we're doing a subtraction, right? This was 11/3 minus 6/3. Here, when we were dealing with the x's, you know, we factored out x squared, so it was 8 take away 2 is 6. So how many are here? 1. And how many are we taking away? -3. So this would be w with exponent 1 take away -3. All right. So, you know, fine. Simplifying that, we have 4x squared, y squared, w to -3. W to -3. And then 10. So this is unchanged. I'm just simplifying that exponent right there. 5/3 plus 7, x to 6, w to 4. Now, again, if you're looking at that negative and thinking, I don't know, I'm a little bit, I don't know. So what if you were to multiply this w to -3 back in? What if you were to redistribute it to that term in particular? Then you'd have w to 4 multiplied by w to -3. And you know, when you're multiplying two things of the same base, what do you do with the exponents? You add them, right? So it would be w to -3 multiplied by w to 4. So the exponent would be 4 plus -3. It'd be 1. Is that what we wanted? Yeah. All right. So now, is this the answer to the exercise? So here's a different question. Have we factored out the greatest common factor? Yes. Now here's the question I originally asked. Is this the answer to the exercise? No. No. It isn't. Why is it not the answer to the exercise? Right. It says final answers with positive exponents. So here's the one that, you know, that's holding up the show. Fine. So then, you know, this has exponent -3. And, you know, basically we want it to have a positive exponent. So if we could somehow make its exponent -3, which is to say positive 3, that would be good. But what's the cost of making it have exponent positive 3? Yeah, by moving it to the denominator, right? Because moving stuff up and down in a fraction causes the exponent to be negative. So you could say, all right, this is 4x squared, y squared, and then now divide by w cubed and multiply by all that. Any question about this one? And again, if you're ever not sure that you landed in the right place, well, you can just multiply that back in. As long as you multiply it back in and you get back where you started, then you're in good shape. Any question about it? So now a few comments about showing work. So like from here to here, so like, you know, this step, we dealt with the x's. You know, so all that I did is I just, you know, it was x to 8 and then it was x to 6. Notably, I didn't write 8 minus 6. I didn't do that. Okay. Now, from here to here, we messed with the y's, and I wrote that. Part of the reason why I wrote that is so you could see what's happening, so you could make sure you understood the mechanism. 11 thirds minus 6 thirds is 5 thirds. Now, I completely understand the motive, the motivation to not show your work. You know, because I'm like the top lazy person of all, right? At the very top. And, you know, that's just a economic behavior is one of the properties of humans. Okay? So I totally understand the motivation to not do that. But, you know, so that one and maybe even, you know, this one too, you know. Leave that one out. But here's the deal about that, is that when you don't write something down, you're depriving two different people of something. So you're depriving yourself the opportunity to look at what you wrote and, you know, consider whether or not what you wrote makes any sense. And you're also, so you're depriving yourself of that opportunity, and you're also depriving the grader of that opportunity. And that second one is kind of the bigger one, maybe, from a point of view of just optimizing your grade. Because, you know, jumping from here to here, if you go from w to exponent 1 to w to exponent 4, all right. You did it. It was a long jump, but you made it. But if you go from w with exponent 1 down to here, and that whole subtract and negative thing, you know, your brain has a speed bump or whatever, and you write, I don't know, anything else besides w to 4, then now it looks like you don't know what you're doing. That's what it looks like. Whereas if you write this step in the middle, if you write 1 minus negative 3, if you write that, then it's clear you know what you're doing. And then if you come here and write w to negative 2, now it looks like you've got a problem with arithmetic, which is different. Not good, but it's different than what's being tested on this exercise. Do you understand the deal? All right. Good. So now let's move on to something else. So we need to define two terms. First one is, its name is quadratic. So a polynomial of degree 2, is called a quadratic. So every such polynomial can be written in this form. So a multiplied by x squared plus b multiplied by x plus c. And there's one requirement, and that is that a is not 0. You know, because if a was equal to 0, then the polynomial wouldn't be degree 2, because there wouldn't be a degree 2 term. Now, I'd like to point out something that's a little weird. So we're saying that a polynomial of degree 2 is called a quadratic, right? And that's kind of weird because, you know, quad means 4. So that's weird. Why is that? Here's something else that's weird, is that when we say x with exponent 2, the common way to say that is x squared. Right? In the end, it is nothing more complicated than just the shape, right? So there's a shape called the square, right? Which is a four-sided figure where all angles are right angles and every side has the same length. So that's a right angle. And then if the height is w and the base is w, then what's the area of that square? W squared. So the fact that we call that x squared is the reason why a polynomial of degree 2 is called a quadratic. Fine. Next is that we have a remark called monic. So monic. So a polynomial with leading coefficient one is called monic. So, you know, in this case, the number 1 is in agreement with that. Mon, you know, meaning 1. Okay, so some examples. So how about this polynomial? So 13x plus 14. All right. So this polynomial has degree 1. You know, it's got 2 terms. That term is degree 0, and that term is degree 1. And the degree of a polynomial is the highest degree of all of its terms. So this is this polynomial's degree 1. The leading coefficient is the coefficient of the term of highest degree. So what is the leading coefficient for this polynomial? Not 1. It's 13, right? So for this one, the leading coefficient is 13. And so is this monic? So it's not monic. How about something like x squared plus 13x plus 14? All right. So now, what's the degree of this? So it's degree 2, right? It's degree 2. And then, so, you know, that means that the coefficient is going to correspond to that term. So what is it? What is that term's coefficient?
1.
It's 1. It's 1 because, you know, you could say that this is equal to, so I'll just copy it first. So x squared plus 13 x plus 14. So I didn't write a coefficient, so the implied coefficient is 1. So the leading coefficient is 1. So is it monic? Yes. Any question about this? All right. So now, just like you can factor integers, like you could say that 28 is 4 times 7. And then you can do even better and say, and also you could take it even further and say it's 2 times 2 times 7. And then it doesn't factor any further. We want to be able to do that with polynomials. So we're going to, you know, a big theme in this course is we will develop a lot of tools to factor stuff. And here's the very first tool. And it's sort of a really specific tool. So this is factoring, and it's the very specific case of a monic quadratic. Okay. Monic quadratic. So the first one, I'll say, how about, all right, so here's the thing. I'll say, notice the following. Observe. Observe. That if we have x plus a multiplied by x plus b, like that, then we could use FOIL to multiply this out and collect like terms. So that would be x squared plus bx plus ax plus ab. Now, looking at the terms in the middle, just the middle ones, do you observe that the terms in the middle have a greatest common factor? What is it? It's x. So I'm going to factor that out and get x squared plus, I'm going to factor out that x on the right so that it looks like this, so plus ab. And then when you factor that out, you can get b plus a goes in there. But for reasons of alphabetical order, I'm going to write a plus b. Okay, so now this representation, so this is factored right here. And this is expanded. And what I'm telling you is that, that we're going to do this operation in reverse. I'm going to start you here, and you have to proceed that away. And the way that you're going to do it is the following, is having a look at this. This means, so, you know, therefore, to factor a monic quadratic, because observe quadratic, that this expanded thing is monic because its leading coefficient is 1, and it's a quadratic because its degree is 2. To factor a monic quadratic, find two numbers a and b such that two things are true. A plus b is the degree 1 coefficient, and 2, a multiply b is what? Is the degree 0 coefficient. All right. So let's have one of these as the last example. So we want to find two numbers that satisfy two things. So here's an example. Please factor w squared minus 15w minus 126. All right. So now, just like on all new topics, the first time I ask you it, it's going to say you've got to do it in this really super tedious way. But it'll just be on those first few exercises. Then after that's done, then you do it, you know, showing less work. But for this, here's the work that's expected. So we're going to perform a search. So we're going to look for two numbers, a and b. And here's what must be true, is that when we add them, what should we get? Negative 15. And when we multiply them, what should we get? Negative 126. So now, what I'm saying is that these two things must be true. And what I want to see is you searching through the possibilities to find something where they're both true. Now, it's easy to find two numbers that satisfy one of them. For example, I could try, say, negative 5 and negative 10. So that's a reasonable thing to consider, because after all, when you add them, what do you get? You get negative 15. So that's good. However, when you multiply them, what do you get? You get 50. So is that what we wanted? It's not what we wanted. Okay, so then I'm going to do a couple more because we're against the clock and say, all right, I need the product to be negative, so I need one negative and one positive. So how about 1 and negative 16? That's reasonable in the sense that they add up to the right thing. But in fact, they multiply to be negative 16, so that's not what I wanted. But I could just as well find two numbers that do this. So how about 2 and negative 63? So those numbers are reasonable in the sense that the product is right. However, the sum is negative 61. So that's not what we wanted. Okay, so then to close, can anyone, I could continue searching, but can anyone see the numbers that we're looking for?
6 and negative 21.
Very good. So 6 and negative 21, because when you add those, you get negative 15, and when you multiply them, you get negative 126. So now we found two numbers that satisfy both, which means that's the winner. So as a result, the factorization is w plus 6 multiplied by w minus 21. All right, that's all for today. Please turn in the odd one on the way out. Barely made it.